Here we're given a situation here that's a little bit challenging to understand what's going on, but once we kind of get started and get our equation set up, the math itself is not the challenging part. So let's go ahead and read carefully and try and visualize this and then create an equation based off of what we're looking for. So to start off, it says we have a shadow of Kate cast on a wall by a light on the ground, which is d meters from the wall. So my light here is d meters from the wall, and we have our shadow that is cast here from the light. We have Katie, who is 162 centimeters tall and is 3 meters from the wall. So first thing I notice here is that we have two different units. So I'm actually going to change this into meters here by dividing by 100. So that's 1.62 meters. That's how tall Kate is. And 3 meters from the wall. So this little distance right here is 3 meters. And so we're going to use that to help create a triangle in a second here. The question here is express d as a function of height of the shadow h. So we have two triangles, right? We have our outside triangle, which is the shadow here, which is h, the distance from the light, which is d, and then that light cast being the hypotenuse there. Then I have my inner triangle, which is Kate, which is 1.62 meters. And then the distance that Kate is from the light, which here's the hard part here is that it's not 3 and it's not d, because remember, this is 3 and we're looking for this distance right here. So really that would be d minus 3, because I'm saying the whole distance is d, but if I take away 3, then that's what's left over. So that's kind of how we set up the two different triangles. And now the thing about these triangles is that they are similar, meaning the angles here are all going to be the same, because again, the light here is creating the same angle, whether we're talking about to Kate or to the shadow. And so it's helpful because then we can say that these two triangles have a ratio that can connect them here, because technically here, if we say tangent of an angle, so tangent of this angle here is equal to the opposite over the adjacent. And then the tangent of our kind of green triangle here, again, it's the same angle. So even if we don't know the angle, we know tangent of the angle is the same. And then this is opposite over adjacent. And because I know these two angles and these two tangents are the same, I can use substitution to plug them into each other, which gives me 1.62 over d minus 3 equals the height over the distance. And now I have my equation. And really, again, going back to what the question is asking, express d as a function of height of the shadow. So I want to get all the d's on one side and then factor it out. So in the math here, what I'm going to go through is I'm going to multiply d by both sides to get it over here, and then cancel this one. Then I'm going to multiply d minus 3 to both sides, which will cancel this one, give me something like this. So when I write this out, I have 1.62 times d equals h times d minus 3. I'm going to distribute h here, so 1.62d equals hd minus 3h. Then I'm going to move this hd, every term with d in it, to the left side, so I'm going to subtract hd from both sides, which will make that go away. Now that I have the greatest common factor on the left side here is d, change up colors here. So I got d on the outside, 1.62 left over, minus h equals negative 3h. Now I divide both sides by 1.62 minus h, and that gives me my final answer here of d equals negative 3h over 1.62 minus h, which now, again, I found d in terms of the height of the shadow.